There it is. Here we go again, and we're going to spend another evening, hour and a half, working on this radio. Now, I picked this radio specifically because it's not the radio I had last week. Because the radio I had last week, we spent the whole hour and a half, almost 2 hours, a small group of us, working away on it, and it didn't go all that well. So let's try this one. That's what I'm suggesting. So. And with me, I've got the Scotty TR. Say hi, Scotty.
Hello, I'm here. It looks like Tom has joined as well.
That's right, yep. And there's Tom. Hey, Tom. And big delay here. So pay attention. It could be an 8-second delay.
Story of my life.
So, well, that's great, Tom. You missed the last week's somewhat frustrating. Well, you watched it though. You watched it afterwards. Somewhat frustrating attempt to get the radio to do what we were pretty sure we had it doing the week before. So, so what we're going to do tonight is we're going to switch to this much more simpler radio, and do our best to get some sound coming out of this one, which we think we were successful in the last time we had this going. So hopefully this isn't a difficult thing at all. I gotta get some kind of view here for you to see inside the radio. So I'm just going to switch cameras here. Okay, and you know what? I've got this guy on fixed voltage, so I'll just hold him. Fixed voltage, fixed focus. Yeah. Okay, if you're still in your chair.
Getting a little nauseous, but.
Here we are. So that's the capacitor. Pretty cool, pretty nice capacitor. And that goes with this dial on front. Okay. And then there's the resistor. Help me with it there, Scott. I got a blank. I'm blanking out. The grid leak resistor. Didn't completely blank out.
The grid leak?
The grid leak, right. Okay, and there's the tube socket. I've got the tube out right now, and you can see some white material. We put that in there last time to force the pins upward so they'll make contact with the tube. So this is the tube we'll use. It's an O1A. Can you see that? Oh, I know. It just throws me off because I'm looking at it backwards in my own screen.
Yep. It's a little bit pixelated, but...
Yeah. Okay, so there we are. So I got that plugged in. Now another tuning feature is this book capacitor, which really kind of blew me away. I'll open it and close it. And if you look, there's a sheet inside there. I don't know if you can really see it. Yeah, you can. And that would be the would prevent a short circuit from happening. And I suppose it has a bearing on the capacitance too, a little bit. But mostly this would be another form of air capacitor, I think. What would you say?
Yeah, I think that's all it is.
Okay, so there's not too much to it. Now there's a very carefully wound coil back here. Now Scott, do you know why they wound coils like that? With that strange cross pattern and basket-like weave? Well, I happen to know.
No idea.
I will tell you. Anytime, well, when you just wind an ordinary coil, you get a certain amount. Oh, there's this other effect, one of these weird effects, um, like the skin effect, or something like that. Whatever the effect is, you can reduce it if you don't parallel the wires when they're close together, or if they're in parallel, keep them farther apart. So, see where the wires cross? They're right together, but they're not in parallel at that point. That's a really rotten explanation, but really, it's easy to find on the internet if you go hunting around. It's a very specific effect that's being controlled by the shape of that coil. Something to be minimized and avoided. But then we know it's right down here is a rheostat. And
What is the coil used for?
well, it's probably working as the inductor in conjunction with the tuning capacitor, which I think is this one. And why there's two, I'm not clear. Maybe Scott knows, or and I see Bobby has joined us. Hi, Bobby. So Bobby may or may not be mic'd. I don't know. So there's this one and the book one. Scott, do you know what it was? This radio is a regenerative set, right?
Yeah, you want to know why there's two caps? Is that what you're asking?
Yeah, two variable capacitors. Yeah.
One might be for antenna tuning, possibly.
That's interesting. I've got a schematic here.
Or it's possible that the guy
Yeah,
building the radio was just trying the two different ones to see which one worked better.
You would think of something like that. No, this is for another radio. It's for my other radio. I don't know if I've ever really hunted down a schematic for this one. But well, we had this thing working, didn't we? Wouldn't one of them have to do with the
Yeah, I think
regeneration?
so.
Wouldn't this have to do with control of the regeneration?
Normally it's the coil that does that. You move the two parts of the coil back and forth to change the regeneration level.
There's no coil. There's no variation in this coil. It's very solid.
So maybe they're using the second cap as the regeneration coil, or regeneration control.
This one here. You're thinking.
Yeah, that could be. You'd probably have to trace out the schematic of the thing and draw it out to see for sure how it's connected.
How did we ever get this going? Figure it out again. Hello, Steve. Okay, so it looks like there's a fair delay for some audio, but maybe not for other. I'm not really clear on just if everybody's getting everything the same moment I am. So, okay. My camera was up. It was up late last night. There we go. That's not too bad. Okay, so what I'm thinking is first we got to put a little bit of heater current into that, or at least hook them up. Now there is a rheostat in there, but I'm not going to pay any attention to it. I'll just control the heater current directly from the power supply. And I can see the pins on the tube here are named. So this one here says G for grid, P for plate. The other two are clearly the heaters. And I can see it go right on a rheostat. I want to come right over to these terminals, way on the far left side here. But I shouldn't need to worry about that. I'll just clip straight onto those terminals. So Steve, you probably didn't hear me say that I'm avoiding the radio we were working on last week because I don't want to go through another hour and a half with everybody and end up again just with nothing. With nothing. Okay, so that's the heater. And then we need to hook up a B plus. And we need to, oh, we're back to this, how are we going to hear this thing? Now, why couldn't I just take a capacitor off the plate and hook it up to my audio amp that way?
I think that might have been what we did the last time. Or was this the radio that you hooked up that resistor? Hooked up that resistor on the plug. Is this the one that has the jack on the front?
Yeah. Right? That's what you're thinking of?
Yeah, one of them you plugged a jack in with a resistor across it and then took the signal off that. Was this the radio?
No, this is a different radio from that. There is no jack, but there are these terminals, and I did put this resistor on for some reason. I don't necessarily remember at this point. But I'm pretty sure those would be the headphone terminals. The antenna in the ground over here, and B plus and other that kind of stuff over there. And what would you want in the middle? You'd want the headphone connection kind of central. And in this case, you got your choice of holes. Many, many holes. So then on the B plus side, okay, so B plus, we'll go from here. Sorry, this is a little bit out of focus. Follow this wire up here, right up to one of those pins. So this would be some kind of, well, maybe we concluded that you would normally have the, I remember it all. The idea was you plug in your headphones here, B plus runs through them, right?
Yeah.
Right.
That's
so
right.
We want to do that, so we put this resistor in to fool the radio and hook up the amplifier here. And that's what we should do. And then B plus.
Yeah, put up a screen capture, a screen share of the schematic of the Crosley single tube one. It's pretty close to what this radio is. I don't know if you can see it there.
Do you want to run through it a little bit? You got to talk, or else you see this.
Okay. Well, yeah. I guess if it comes up on the screen when I talk, you can see. You're right. The B plus goes through the headphones, and then through that coil, and to the plate. That coil is part of the regeneration, but on this radio it doesn't look like it is, because usually there's two parts to the coil, and then you move them closer or farther apart to vary the feedback in the regeneration. So maybe this one has a cap that's varying for the regeneration.
I see where the book capacitor is.
Yeah, on the schematic there, it shows it just in line with the antenna.
Let's see if I can actually see that then. So the antenna connection, this one right here has the word antenna right on the handle. So that's this. You can see, maybe see it better on the camera actually. So there's a wire shoved in the top here. Where's that going? Hang on, you're going down. Goes way down here. I have no idea what that is. That's going way over to this other capacitor though. Well, that's interesting because you suggested the other capacitor might have been an add-on or something like that. This one here. Because it's not showing on
Yeah,
the
it could be an
schematic.
add-on, or just could have. Right. But maybe the guy was just building a radio with the parts he had at hand, and that's how he did it.
Okay, so then what we're really looking at is, or are we looking at it? Yeah, you have this coil and this book capacitor, and we're just, no, there's no resonance between those two. So the only purpose of the coil is to feed stuff back. And the book capacitor resonates the antenna.
Because that's kind of what it looks like from that schematic. Is that book capacitor connected to the antenna, or is the other one?
You know what? I got a big whack of chat messages here. Oh, so this is where all the communication's going on. Aha! I wonder why everyone's so quiet. No, no one's quiet. I didn't pay any attention to that. Okay. You're going to have to speak to me to get my attention properly. He says very forcefully. Okay. So, we're getting back to the question of where the B plus goes. It's going to be on one side, one of these two terminals. Well, it's going to be over here where the B plus is. Oh. Oh, was my headphone stopping? B plus, B minus, B plus. This wire to here, to this terminal. So that's the same as the B plus here. I can hook it up over here. Hey. Okay. Hang on while I free up my hands here. Yeah. Okay, so B plus positive is going here. B negative. It's going to go where? Where's that going to go? To go onto one of the heaters? Speak there, Scott, so we can see the schematic again.
Okay, well, I'll put the schematic up there. The A plus and A minus are just going across the heater through that rheostat normally. And it looks like the B minus connects to the A plus on that schematic. So
It's connected
is that
to
how
the
Tracy's
ground.
done it in there?
See, it has a big ground piece in there, in the schematic.
Yeah. Yeah, in the old days it looked like they decided they needed a ground on these, but none of the radios I have from the 20s, I have none of them grounded. I get pretty good reception just with 3 or 4 feet of wire hanging off as an antenna. Then we've got all these powerhouse stations around here, so it probably doesn't take that much to get a signal into them.
Okay, so something that would look like ground is going to be could be the frame of this capacitor. Here, let me just put this a little bit like that. Okay, put this on here. There we go.
I think the other guys should talk too. Everybody's sitting there so quiet. There's no reason why everybody can't participate. That's the whole reason to have them connected here.
I suppose I could put it onto this B minus terminal. Do that. There we are. Steve steps up to the plate.
Where did you find
Yeah.
that schematic at then?
No answer comes to reply. I think, Scott, how would you like to
Yeah.
can you
The
step out and
schematic-
come back in and see if your timing delay, because it's your delay that's going on there. See if you can get rid of it by coming out and coming
Oh.
back in. Because I don't, Steve, are you hearing
Oh,
me
yeah.
delay, you and me?
Yeah, I'm hearing everybody fine.
Yeah, but see, Scott, since we started, Scott and I were going for a couple of minutes just before I started the whole thing up. And right away, there's this huge delay. So maybe if you don't connect right, you have to connect again or something.
Heard.
We'll see. Okay, so I got the minus on. Better put on a voltmeter.
Looks like Bobby's trying to talk there, but I'm not getting any audio from him there.
Hello, Jim. Hello, Scott.
Hey, Bobby.
Hello, Bobby.
Hi, Bobby.
Hey, Steve. What are we working on today?
I don't really know what it is. What is a regenerative radio out of the 20s? Probably put together as a kit or from just, parts in the part box and stuff like that.
Yeah, it has no model or...
No, it's and I'll show you the front of it here.
It kind of looks like it's a home built from something that he used to try different radios with.
Yeah, here's the front of it, and you can see it's full of holes. So this thing's had a few versions.
Yeah.
Whatever. So it looks like some guy put this together, and just to give you a quick tour through the inside of it here. So okay, here's the A capacitor, which we're not sure just why it's there. A coil here, a fixed coil, a book capacitor over here,
Yeah.
and the usual grid leak resistor detector type system there, and only one tube.
That's simple enough till I could just about build it. Just
Well,
about.
Yeah, well, that's one of the reasons why it's fun to work with. It's so simple. I mean, it didn't get much simpler. So I think I got heater connections. I think I got the B plus connection. I don't have the audio hooked up yet. Or that's a bad thing to do. Scott, did it get rid of the delay?
I did not because you started talking to me as soon as I was going to. You want me to disconnect now and connect?
Oh, you haven't done that yet?
No. I'll do it now.
Yeah, go ahead because it's a long delay.
Okay.
It's a long delay. That's for sure. Okay. Thin, we're ready to go. Oh, just have to put this tube in. Okay. Just untangling some wires here. So we don't have a disaster take place. Okay, and this meter will be reading the B+. And we're just giving Scott a moment to get back. So, Steve, have you ever worked on anything like this?
I've got a little Causley. I think it's a 52. It looks a lot like this, but you know, yours is got a little more real estate than the Causley. The Causley's pretty small. I think. Does Scott have a little Causley like that?
Well, he's got a number of commercial radios, and I'm sure one or two of them are Crosley's. Well, would you have one with a book capacitor in it?
Yeah, that's where I think I commented on your video that was a Causley book capacitor because I've got one. It's got one in it.
Oh, I see.
It's a little tighter, and I think mine has the regen coil is on the front, and you kind of push this knob in and out to move the coil back and forth, kind of near the phase.
Okay, I wonder if Scott's having trouble getting back on.
Jim, in regards to the delay, one thing you might do is have a clock in the picture so we know what the time is that we're viewing versus the real time.
Oh my God, I would need a really accurate clock.
It doesn't have to be real accurate.
That's a tall order for me. I do have a really cool clock. Let me just grab it.
Is the delay between Scott and Jim, is that where it's kind of picking up, or do you guys know?
I think that's what Jim was saying.
We just kill a bit of time while that must be Scott coming back there. Oh, there he is. Okay, but let me show you my really cool clock first here.
Yeah.
So I got this because it kind of looks like vacuum tubes, I thought.
A Nixie.
Yeah,
Well, that's what they're really trying to imitate is a Nixie tube. But
Oh, it isn't a true Nixie tube?
no. Okay, so anyway, that's good. Scott, I was trying to run a dog and pony show there while you were away. So are you still on the delay, or what do you think?
Must be.
It looks froze from here.
Yeah, I guess he's having some kind of problem at his end tonight. So, okay. So we'll carry on.
Yeah, I'm connected here. Not sure you can hear me.
Yeah, your voice is very distorted.
Now we're all silent. Yeah, that's
We're
not
all
going to work.
waiting.
That's
What do
not
you
going to work.
What do you
Scott,
say to that?
We should carry on. We'll carry on.
go up, put the pointer on the screen, go up to where it shows a bunch of bars, like kind of on a cell phone. It says adjust bandwidth usage. See if there's any adjustments you can make that might help with that.
Right in the middle of the page?
Yeah,
At the top, yeah.
at the top, yeah, the top
yeah.
center.
Yeah. Yeah, it says adjust bandwidth usage. I'm preaching to the choir here, though.
Yeah, mine's set to auto and maximum, I guess, or to the right. So about 2 or 3 minutes, Scotty will hear that. And,
Yeah.
so,
Nice.
That's
Okay,
too
well,
much.
what,
It takes 2 or 3 minutes for the audience to.
it's kind of like the laugh kind of rolls through the
Okay.
audience. You know, it's the
That's
joke
what I was
kind
going to
of-
say.
Yeah. This is a strange affair, isn't it?
It's still cool.
Well, I think what it is we're on the edge of what's possible right now.
Yeah,
And,
plus you've got Plus, you've got 1, 2, 3, 4, 5 people on at the same time. That usually slows it down.
Really?
That's what I've noticed with other people's shows.
Okay, so shall I apply a little heat to this tube here?
Go for it.
We'll see if it warms up. Oh, I gotta turn on my sound amplifier here first. Let's see. There's the sound. That's the sound. Okay. Boy, my shop's a little messy.
What tube are you using in that?
That's a O1A.
Gotcha.
Okay, so I'm ready to start cranking her up here.
I turned mine way down. Hopefully that'll help Scott.
Oh, I don't think it's shared that way. Because I'm turning up the voltage here and I get 0 current. 0 current.
That doesn't sound good.
Okay. We're up again.
Is there
Oh,
some?
Oh, it's gonna go.
Is this where things break into flames?
Not with this much current, no.
Rats.
Much
You gotta make sure you don't let the smoke out of the wires.
Right. Oh, I remember this. I think we got this working. I had to hold the tube the whole time.
This is when you put the paper under?
No? Yeah. I put paper into this one. And I think in the end I had to hold the tube, which I am doing
Gotcha.
now. I'm holding, and it's taking a little bit of current. So I don't hear a radio. Okay, so I'm gonna let go of that, and we better hook up the antenna. But I'm gonna be smart. I'm gonna hook up the signal generator. That is smart. Man. Okay.
So is there some irony in this? We're using, pretty advanced technology to mess around with a 1920s radio.
It's completely. I'm not sure irony is the right word for it, but it's not lost on me what goes on in my shop. When I look for a schematic, I bring out a little tablet, things like that. It's not lost on me how bizarre. I'm in the Netherland of technologies or something. Got the antenna on. Looking for a ground. Maybe I should just clip across the coax. Whatever that provides. Signal generator. Oh. Who's got somebody's got something playing in the background.
Pardon
It's
me.
Steve again. Yeah, it's Steve again. Yeah, there it goes. When the baby started crying, I thought, okay. Okay, we have heater heat. Oop. Oh, I need to put on some B+. Okay, we're B+ing now. And that meter is on the 50 volt scale, so 15, 20, 25, 30 volts.
Were you able to sort out what that weird effect was with your B+ last time? Remember the meter seemed to kind of stick at certain places?
No, I never experimented about it, but I'm left with the impression it's the output from the power supply that does that itself. But I didn't go and experiment to find out. Okay, so we are now listening to it for whatever that's worth. Let me swing the frequency generator around. Put it on. I'll turn it up. It's putting out a pretty good signal. That's the heater disconnecting. I like that. It's more than one that's a bad contact. That's kind of crappy if there's that many bad contacts down there. Why would it be that bad? I think I got to get the tube. I got to know the tube is connecting, or this is going to be a big waste of time. I mean,
Can you stuff something more underneath those contacts to make them a little
I'm
more?
thinking that it's making contact.
Springy?
It's not making electrical contact. Well, these are really shiny down here, the tube ones. But the surfaces down there don't look 100%. I'm going to use a pencil, but 30-year-old pencil eraser is not so good.
Don't forget to turn off your voltage before you start.
Did that. Yeah, I already got both
in
of them on.
the tube there. Okay.
I don't know. I don't think it's doing much. It'd almost be better to clip the tube using clip leads. After all, why are they using a socket? They're using a socket kind of almost for commercial reasons, if you like. I could clip lead to this tube completely.
Yeah, that sounds like a very good plan.
To the pins. Last week I learned best to not be operating these on their sides. I almost had a heart attack when I read that. So, because I mean, yeah, I shouldn't have taken too many brain cells to realize that. So it would have to be held this way, or perhaps like that. This would be a good way. This would work good.
Yeah, I kind of vote for the upside downy one.
You just kind of lay it in here, and by the time I get clip leads on it, it won't be going anywhere.
Maybe a coffee mug you could put it in, and that would give it a stable spot to stay vertical.
Something to smash nicely into. Maybe a coffee mug may not be the best. Excuse me there, I was just taking a slug. What do I have? That might be a little tiny. A little tiny.
You have a cardboard tube or something?
And not one this big. How about some cottage cheese? With a little bit of other odds and ends in there. There we are. It's pretty ironic. Look what's in there. There you
What
are.
is that?
Alright.
Oh, transistor.
Yeah.
A transistor.
Sticking this old tube in there with it. Okay. one big pin. Other big pin. So those are the heater connections. Now, you want to. I gotta pretend here. Okay, so I'll do this one. Going to this one. Actually, this is looking pretty cool. And then, of course, that one must go to that one. It's like a heart transplant sort of thing here, you know, with it's kind of outside the body. Those Russian doghead surgical experiments, something like that. And there's some pretty bizarre videos on the internet. Okay, so I think now we're ready to go with far more certainty in the connections.
I thought you were going to say, now we're ready to go, boom.
I hope not. Okay, so I'll turn up the heater, and there's the current. Fine, no question about that. Turn on the B+. Oh. Well, that's probably just a hum from the power supply reaching the amplifier now. They don't have any B+ yet. Here comes the B+.
Do we have any glow on the tube?
Well, I can see the current on the meter. Yes, we do. Yes, we do. Look,
Super.
I'm turning the bulb and all, or tube and all those. I should not be doing this. But definitely it's going. It actually has a yellow glow in it. Take it down just a little bit. Now, you know, to what degree are we crazy that we think this is going to work at this point? It's not going to work without this connected. Yeah. Okay. Turning the book capacitor. Could make a hill of beans difference. And the other one. Something. So now I'll scan through with the signal generator, because that's what's feeding its signal into it right now. It's not the antenna, it's the signal generator. So I'm starting, excuse me, well below the AM band. Okay. I'm well above the AM band, coming back down. coming into the AM broadcast band region.
Does the polarity of the filament, does that make any difference? You get the thing to oscillate?
Well, we don't want anything oscillating in this. So let me just see. So I don't know if the polarity makes any difference. So let's remove the heat from the tube and see what happens to the sound in the speaker. I would say nary a thing. Nothing happened there. So I'll turn it back on. Maybe I'll crank it up a bit. Okay, so I cranked it up a fair bit. I didn't hear any changes to anything.
Does your
Maybe you could check the make sure the grid leak resistor is making a good contact to its little socket or whatever it's in.
That's something, Scott, as you were saying that, I was reaching over to do exactly that. How can we tell for sure? We should check this resistor. We did check it once, didn't we?
I believe we did, yeah.
We got this thing working amazingly well. Am I remembering it right?
I'm pretty sure this is the one that we got tuning in that station in Nashua.
Are you getting B plus on the plate pin there?
Good question. This resistor is measuring 6 megohms. Okay, so check for B plus on the plate. That's interesting. Okay, something funny happened there. That's the grid. That was the grid I was touching, and there was a fairly large negative voltage there. I touched it and it bled away through my voltmeter. That's what it looked like. So here's the plate. Plate, yeah, 26 volts plate. On my other meter here it says about 27. It says 27, so this is actually pretty good. Could it be that I got the audio the wrong way? I should ground it on this side.
I kind of wonder if that negative voltage wasn't
It's worth a try, I guess.
Well, yeah, let's investigate the negative voltage before we give a try switching the audio. Okay, well, I'll put the meter where you guys can see it here. Okay, not there. Not out. Got everything on a funny angle here, so the camera's looking down into it. Oh, Okay, so I'm going to touch this to the grid. Everybody watch the meter. You see that exciting thing? It wasn't so exciting.
I must have missed it.
It was not very exciting. There we go again. Okay, so I was a fool and I looked at my computer screen, which is all ass backwards. So I don't know what happened just now. What happened? You guys were looking at it straight.
I didn't see any change on the meter.
Oh, it jumped all over the place.
Oh, I guess that section of the video I dropped.
Okay, I'll watch the meter this time, like I should have. Here we go. Didn't do much of anything. Just hanging around minus 0.4 right now. Like something has to have time to charge up. Okay, we'll try it again. And a different sound comes out of the speaker too. Are you noticing that? Here we go. So it was basically a little over 1 volt positive, and it switched around to minus 0.3. 1 volt positive. There it is. No luck. Well, let's see what happens if you just fool around with the antenna. There's no noise at all. Well, that says something, doesn't it?
I think when you get the regeneration happening, you should be able to get it to break into oscillation by manipulating the voltages of the heater and plate.
That'd be like step 1 is to get it on the verge of oscillation and then start seeing if you can receive something.
Yeah, sounds like the way that would normally be done back in the day.
The rheostat doesn't play any particular role with that, other than just adjusting the heater temperature.
Right.
Well, I haven't seen that it's anywhere near oscillation. I haven't heard anything like that. I think I've just missed
What
it.
heater voltage are you putting into it?
Right now, the voltage is around 3.5 volts on the meter, and the current's I don't know, 100 milliamps.
Okay, I think it's going to have to be higher than that before you get much action, I think.
Okay, so I can. These would normally be run at 6 volts. 5 being a comfortable
Have you
place.
got a midge? Have you got a midge flying around in your shop there?
There is something flying around.
Because the city has been overrun by midges the last couple of weeks.
No, that's not a midge. That's a moth. Yeah, it was crazy.
Okay.
Actually, one of my videos, you can see them all out on my deck. It's crazy. There's
Yeah.
clouds of them in the sky, and you go outside and they're everywhere. They're in your hair and everything. Okay, well, I can, this thing's going to glow like a light bulb soon. The way I'm going here with it.
Yeah. Well, it should be able to stand 5 volts with no problem.
Well, I'm well over 5 now. See it in there?
Oh, okay. Yeah.
But I'm still under a quarter amp. What if we try a different tube? By cracky.
Oh, there's a plan. That's why it would be in a socket.
We have the technology. And another tube. I should turn the B plus down too, maybe. A heater. That's the other heater. Did I pay any attention to what I just did? I don't think I did. That's daydreaming away.
You mentioned the heater.
I got the heaters right. So plate should be there. Okay. Way to go, subconscious. You did it. Okay. B plus is there. 25 volts on the B plus. And on the heater, here we go. And we're about exactly the same spot here. It's glowing a fair bit. Okay, so I suspect the way we think we're going to hear it, is there something wrong with that? Let's verify once again B plus is reaching the... That's interesting. If I put a signal into the grid and we hear it coming out the speaker, that proves that things are working to some degree. If I'm not good enough. But what was good enough was using the voltmeter. Problem is when I use the voltmeter, it does that voltage drain off effect, making the grid more negative. Making the grid more negative. Does the grid have to be positive for this to work? I ask.
Well, according to that schematic, the grid is just going through the grid leak resistor and capacitor and through the coil to ground. And then getting some feedback from the plate circuit through the coil to cause the regeneration.
I see that. We could assume the coil in here has those as two components, and so it is providing the feedback.
Have you got 4 wires, like 4 connections to the coil?
Good question. Okay, there's 2 here. The two of them are the antenna. They're attached to the antenna. And then there's one here. And there must be another one. Oh, I have to look close. One of those wires is actually 2 wires. Here, just hang on, let me get a good Let's look here.
Yeah, because if you look at the schematic, the B plus goes through the headphone and then through part of that coil to the plate.
I don't know if you guys just heard that or not. The sound of a goal being
You
spotted.
watching a hockey game?
Yeah. Yeah. Okay, so looking at the coil. It's easier to see on the camera than it was with my own eyes. So this wire here, 2 wires, and then there's this wire. I'm looking for its brother. It's a fairly heavy wire. I don't see any wire down low. Well, this would be his brother right here. Right, hey, come on, over here, over here. Okay. In fact, those are all the lead wires there. Going there. So let's look at this twisted pair of wires. Does it really separate at the far end? Or they just twisted together somehow? Oh, hey.
Looks like we just lost Tom.
Well, he probably fell off his chair. So okay, so those wires are just twisted together. But they could they be 2 ends of 2 coils? So it's kind of like a center tap sort of arrangement, kind of. Pop the schematic up there, Scott, if you would.
Yeah, it could be, because the Crosley radio has that little thing with the wiper that connects various points of the coil to change the tuning range. So those might be just connected together to set one tuning range.
So you're thinking that this is 1 coil, not 2. Is that what you're saying?
Well, you would have to have 4 leads coming out of it connected separately in order for it to work the way it shows in the schematic there.
Oh, if you had a selector switch like that. Well,
Yeah.
this might be my imagination, but I think these are 2 different sizes of wire. But when I look at the coil, it looks very, very uniform. And you could just, I'm thinking this is a different size wire from this, and that would suggest there's 2 coils.
You might have to do a continuity check just to see for sure what's connected to what.
What a good idea. What a good idea. Okay, so one is, might be better without B plus or anything going while we're doing this. So here's one lead, comes to here. And the last one's here. Okay, so that seems to be the case, that they are actually 2 coils connected in series. That's what we could guess this is, but that's not a good guess, because the center tap, if we can call it that, comes to this terminal. And that terminal is what? I assumed it was a ground terminal. It's got a different knob on the front here. It doesn't have a word on it. There's nothing engraved. Well, I would have assumed, though, that that's the ground. I think it's a really good assumption. So that means, so does that make sense? That the center tap sort of thing would be grounded?
Well, that's what it shows on the schematic. That the tap is through that selector switch going to ground.
except in this case there's no switch, it's just wired that way.
Right.
Okay, but well, yeah, you keep talking. I can't I can't talk and see the schematic.
Okay, I'm sorry. Yeah. So, right. Yeah. So you got one end going to ground, and then the other end going up to where the grid leak resistor and cap are. You should be able to confirm that from tracing it out, maybe.
The other end going to the grid leak and cap. No, the other end, one of the other ends goes to the antenna connection.
Yeah, that's kind of what it shows. The antenna connection through the book cap to the grid leak.
Now the other end goes through the book
Part of
cap.
it.
The other end goes. Well, here, look. You can. I'll show it where it goes. So here's the other end, right here. It's going along here, disappearing down behind the book cap where it makes a connection on one side. And then there's a wire continuing on from there. This is it here. Comes all the way over and reaches the grid leak.
That's exactly what you should see according to the schematic.
Well, that shows the book
I guess I have to talk to the
capacitor.
schematic to go up there, right?
No, you know, that shows the book capacitor directly in series with the antenna.
Right.
But I got the book
What's
capacitor.
the other side of the book? What's the other side connected to? One side of that coil is going to the coil. What's the other side go to?
Goes to ground. So you got one side of the coil going to ground, one side of the book capacitor going to ground. The other side of the book capacitor going to the other side of the coil. So the coil and the book capacitor are in parallel.
Yeah, that's right. That's your tuning circuit there.
At what point is the antenna connected?
Well, the antenna goes to two places. It goes into the coil on one of the outside legs, if you like. That's a really weird thing, isn't it? So these two coils are wound in each other. They may be the same wire. Maybe what they've done is there are two coils in here. There is one that's working with the antenna, and the other one is picking up from it and conveying the signal further into the radio, resonating with the book capacitor, in fact.
Well, hang on a second here. I'm lost.
And then that other coil, that outside, if the two coils are they're wound together, they look like one, but they're actually two. The other one is wired in parallel with the other capacitor. That's what I'm figuring out here. So you can resonate first an antenna coil, and then you're resonating a second coil. So it's basically an air core transformer going in this thing.
But somewhere along the way, there has to be something coming back from the plate circuit to cause the regeneration back into the grid circuit.
Unless that's not a feature of this radio.
Oh, okay. I think I see what's going on here. This doesn't have a feedback coil. It uses that other cap. Is there a cap to your right on the camera there? There's another cap here, isn't there?
Where's that? On there's the only one that's in here, well, other than the book capacitor and this other one here.
Ah, there you go.
That
Okay.
one,
I think
Yeah,
they
that
call
one.
that a throttle cap.
a throttle cap.
Yeah. Okay, now I see what's going on. Scott's schematic leads me to believe that there should be a variable coil like the Cosley 52. This one uses the throttle cap to control the thing. It's a little unusual.
And-
That coil you got there looks like it must have they must have tapped it to make two separate coils. Is that what I'm seeing?
I think that's basically it's one winding with a tap in the middle somewhere, or somewhere in it. We don't know that's in the middle
Okay.
with this one, with this capacitor, and the other coil is resonating with this capacitor, and what's resonating on this one, the book capacitor, is heading over to the detector,
Okay.
on into the 2. So
I
basically, you just tune both these guys.
The book capacitor is probably the RF tuning. It tunes in parallel with the actual coil. The other capacitor, the one with the vanes, is the actual controls the feedback and takes the thing in and out of
If that's the
oscillation.
case, it must be connected to the plate. It must be connected to the plate circuit somehow. Does it
Yeah.
look like it's connected to the plate circuit?
Well, let's see. Let's see where it's going. So this is a ground wire, it looks like. Well, it's hooked to antenna. So I'm mistaken. So this is the wire that's going probably to the insulated part of the capacitor. I'll take this gigantic meter out of here. And then the frame should have a wire attached to it somewhere. Yeah, it's pretty darn ugly down there. I think I remember. Oh, here it is, right here. Here it is, right on the back here.
There you go.
Yeah. So, oh, that's really loose too.
That might be
that's
a
coming
problem.
up. That's coming up to the. I think this is basically a ground terminal. No, that's a plate. That's the plate.
And that's what
Oh,
Scott
so there
said.
you are. Yeah, there you are. So there's the plate connection, and it's really wonky down there. Let me give it the once over here.
There you go. This radio has very interesting construction. Am I seeing this right? Is most of this like hooked together with those little clips?
Fan stock clips. Yeah.
Yeah.
Okay, so that's better. That's not so flimsy anymore.
Yeah, I think that might be your problem.
Just checking the other ones. Here's another one that's really flimsy. It's certainly not good to do two wires into one fan stock connector. You gotta. It's funny, like the wire they're using, we would never ever consider using something like this, but this is what they must have had. Cloth covered wire. Oh, just scared the living. You know what? Out of me there. Okay, so got the wire hooked up. Now we're ready to try it again. We've changed a couple of things. It could be different this time. Could be different. And then we're pushing 9 o'clock. I'll have to, unless things get really exciting. Which is usually what happens when we do this. Just about the time I'm thinking, that's enough. Things start getting exciting. Okay, so heater first. Bring up the heater. Okay, we're heatering. Bring it up to B+. 30 volts. Bring up the volume. Bring out the Hellmans. Okay. I don't know. Let us tune. Seems to be we had more effect before we tightened everything up. When this capacitor was closing, we were getting some kind of radio-ish effect. Excuse me. There's a steady 3.4 volts on that terminal. 3.5. 3.6.
On the grid?
Yeah.
That's not right at all.
No. This connection's really loose.
Something's going on.
Something's happened. Before, remember, I would take the reading and it would look like something was there and it would disappear. 3.8 and going up. I'm going to crank back the current on the tube. The grid's going more and more positive. That's not good, is it?
No.
No, don't think so.
Yeah, let's stay in 3.8 volts. What did we do that's different? You know what? I got no signal feeding into this thing. What did I do with the signal? So you're thinking, Steve, this could cause feedback. The bigger capacitor.
I believe that's how they call that the throttle cap. That's how they control the feedback. The other circuit is to tune the radio.
So I'm playing with the heater current. And the B plus.
But do you still have that 3 volts on the grid?
Pretty sure. It's not going anywhere.
Well, if you got that there, then the tube's cut off. You won't go anywhere.
It's over 12 volts there. Knocked it down, way down.
Something.
7.6. The grid leak resistor. Hey, pop up the schematic there. Schematic man, speak.
Okay, here comes the schematic up on the screen. Grid leak resistor is connected to the grid, but the way yours is connected, on the other end, of grid leak resistor, what voltage do you have?
Oh, interesting. Okay, so I just saw 5 again on the grid side, and on the far side of that capacitor. The far side of the capacitor is minus 0.2 right now. 0.3, 0.2, 0.3, 0.2, just cycling. Funny. So that's what's there.
I think something's happened to your grid leak resistor.
And now, I go the other side. Wow! There's 15 volts there. So it's adopting B+. That's probably leaking through that capacitor. Is that possible?
No, it's picking up a charge off of the plate. The grid leak resistor isn't doing its job. It isn't bleeding off the electrons.
Yeah, I agree.
I don't know what... 6 meg seems a bit high, but I don't think it's out of the realm. 2 is pretty common, isn't it, Scott?
Yeah, that's normally what the ones I have are in the range of 2 to 4 meg, and they work just fine.
I mean, aren't a lot of those just some carbonized something or other in a tube?
A nice paper, isn't it?
Yeah, a lot of them, they look like a fuse. It's just a
Yeah.
piece of carbonized paper
Gotcha.
sealed in a glass tube.
The heck?
What happened?
I dropped it on the floor.
Maybe you fixed it.
Well, I fixed it. It's very hard to read the resistance on this thing. It's rolling around.
Do you have a couple meg resistor, just a standard carbon resistor?
I surely do.
That would be a good substitute. That way you won't...
And there's nothing particularly special about that
Yeah.
resistor, except back in the day, that's what they had to do to make a 2 meg resistor.
Exactly.
I have a few right here.
Might be a good substitute. They're metal film, right?
Would it matter?
No, I'm just teasing. I don't think it would. I've seen them as low as 500 or half a meg.
Hmm?
I've seen the value as low as half a meg.
Okay, well, there's our grid leak resistor.
I think our RF, we're kind of getting far afield from RF design here a little bit.
Oh, you think that's a little sloppy, those
No,
wires?
I really, I really don't think it'll matter. It's just funny, you really,
I think when you want to optimize it, then you got to do all that other stuff.
yeah, you go a few megs up, and that would definitely go out the window real fast. It's just funny.
Okay, so I got 25 feet plus.
Now see what your grid leak resistor is doing on the grid.
Oh, hello. I have a problem with my headphone plug here. Oh. Problems with everything. Okay, having a look. Whoa! You heard it, but I had this on. Ohms. That's it. That's the value. Whoa! I had it on ohms still, so. Here we go again. So we're seeing minus 0.1, 0.8, 0.08 rather, plus 0.5, plus 0.6, plus 0.6. No, still doing the same thing. When I first put the voltmeter on, there was 3 volts there. So you think that's a tube thing that's happening there? Is that right? Steve, that's what you
Maybe
think?
that the grid leak cap. Maybe the grid leak cap has got a resistive part that's. Oh no, that would do the opposite, wouldn't it?
Yeah, it would take it to ground.
Yeah.
Turn your plate voltage down a little bit. What are you at? Like 30 volts or something?
25.
Nah. I don't know. If the tube were oscillating, that voltage would become negative, wouldn't it, Scott?
I think so. If you
Right.
put it on AC, your meter, and put it on there, could you measure an oscillation? If it was oscillating?
Isn't the idea that when the grid swings positive with a signal, a little bit, it picks up a few electrons, and that charge is eventually built up on the capacitor and produces a negative grid voltage. That keeps the grid negative enough that there's no positive swings. And then it's just, it's got this resistor leading along. That doesn't ring a bell, eh?
No,
Yeah.
I think it's the
drive the tube into nonlinearity.
I thought it was the opposite.
Right? The tube has to be nonlinear in order to detect. It has to be working like the diode. So I think you're driving the tube into a nonlinear.
There's a single clap of applause there for somebody else. I've read a couple of times on the grid leak thing, and it's actually quite complex what's really going on to generate the nonlinearity to get a detection occurring. And it has to do, you know what it has to do with? The positive swing is eaten up by current flowing in the tube. The negative swing is not. So you end up with a non-linear output compared to what you're putting into it, because the positive side is messed up by the grid leak resistor system. It's kind of how I understand it. And apparently, I'm the only one who understands it.
Yeah, and it kind of does that in the audio range in order to do the audio detection, while the other part of the range is still being amplified, the RF.
I'm getting a headache from this buzz. I don't know about you guys.
Okay. Hang on a tick here.
I got it.
We consult the Book of Armaments here.
And the book says.
Without the grid leak resistor, basically the plate keeps going, or excuse me, the grid keeps going more and more negative,
Negative.
and then it cuts the tube off. With the grid leak resistor, it's held at more ground and run into a nonlinear. Yeah.
Well, then it's going positive because there's a leakage of B plus through something.
Yeah, that's not right.
It could be.
Is it possible the tube itself is leaky?
I suppose that's what's happening.
I suppose it's possible. We've done enough changes. I'll put the other tube back in.
Yeah. Is that cup that in? That's from the Dairy Council, right? That's RF approved.
Well, if we were using higher frequencies, it would have to be microwave safe.
I need
It
the
wasn't
Mission
that I did.
Impossible. I should have the Mission Impossible music playing when I'm doing this. So my favorite guy, I can't remember the character's name, but he was the black guy who would always open a panel and put on some clip leads and get whatever effect they needed in their mission. I just thought he was the genius of the whole thing, the young unsung genius. And he had that nonchalant sort of character that he played, his expressionless face all the time. He was my hero for sure.
That was Greg Morris. I can't remember
Greg
the name
Morris.
of the character.
Yeah, that's it.
Yeah.
Okay, so I'm putting on some heat. We are heated. Put on some B plus.
Yeah. Get out the clip leads and run a bypass.
What's that? And now, the exciting moment. Here we go. Exactly the same. Exactly the same. Once again, we've been defeated completely by one of these radios.
Yeah, but it was fun while it lasted.
We got to get something to come out of one of these. But I got to call it quits here because it's too late. It's gotten too late.
That's okay. Is this something you own or is this somebody else's?
This is mine. This is my baby.
Maybe if you get a little time, you should kind of.
Garage sale.
Yep. Picked it up at a garage sale for nothing. Maybe I should sell it back for nothing.
Nah.
It's too much fun. Okay. So just 1 second there, Steve. Hold
Go
on.
ahead.
And I'm just gonna. Oh, Bobby, I forgot you were here too. So guys, just hold on. We'll say farewell to those watching the video on my channel. You could say goodbye.
Goodbye.